Thunderstorms. Now, again, similar to the winter storms, these are things that we experience fairly often, especially now as we head into spring. But how can thunderstorms turn catastrophic? Well, hail can be catastrophic, and then more so, especially tornadoes. So let's talk about how all those things kind of sort of come together. So we're still working with middle school Earth Science Standard 2-2 and 3-2. And basically by the end of this, we're going to be able to start to interpret some of that weather data to predict potential meteorological disasters. So being able to look at the weather data coming in, looking at radars and things like that, and being able to see, okay, we have the makings of tornado, or we have the perfect situation for hail to start forming within our cumulonimbus clouds, things like that. Okay, so, and these things can change Earth's surface at any point in time. So we are going to talk about all three of these major events and then talk about some of the mitigation things that can occur to make these more catastrophic things less catastrophic in our worlds. So make sure you have your notes out in front of you. They are a little bit longer, but I promise we'll go over a lot of big information. So the ingredients of a thunderstorm. We're always going to start out talking about the ingredients of these storms. So what makes it perfect to where, like today, we're not going to have a thunderstorm, sort of a thing. So warm, moist air. And I know some people are like, oh, that word, but it's the only word I got for you. Okay, so this is essentially just warmer air that is able to hold a lot of water vapor or moisture. And it just needs to be present. This is why in the summer we have more likelihood of these types of storms rather than in the spring or winter. Rising air. So as the diagram kind of shows, we have this air, this warm, moist air that's able to go up. We've learned through convection that warm things want to rise, cool things want to sink, and they continue in this sort of a pattern. So this is creating the uplift of that moist air into colder regions of the atmosphere, causing it to condense slightly and things like that. And then instability. This is where the atmosphere isn't able to really resist the rising air and allows it to continue moving upward. So allowing these big thunder clouds to form as high up as possible. So this is important because it's essentially just adding more and more and more fuel to this already developing storm. So let's talk about these storms. These storms do have a life cycle. I think we notice it because sometimes we like sit there and we're like, oh, where did this come from? But then also like, oh, where did it go? Sort of a thing. So there are three major stages to a thunderstorm. We have the cumulus stage. This is where we get that warm air like rising and building and creating these really big, pretty like cumulonimbus clouds. Cumulus clouds are like the cotton ball sort of clouds. But when you think cumulonimbus, this is the big thunderstorm anvil sort of cloud. The mature stage, this is where updrafts and downdrafts coexist, where you get this like push of air up, but also a push of air down. This is what is going to cause for that heavier rain. So for it to come down much, much more vigorously, things like that. It allows for more of that lightning and thunder and strong winds to occur because of the amount of movement. This is the most intense stage, the mature stage, producing a lot more of that like typical thunderstorm sort of esque. And then finally, the dissipating stage. Just as it says, this is where things start to weaken, where precipitation starts to taper off and the storm clouds spread out and kind of eventually just fade away. It's something about those updrafts and downdrafts when they go away that things just kind of mellow. So this is where maybe there's little trickles of rain now and then, but yeah, so those are most of what's going on. Now, these pictures are great in just like kind of showing you what a thunderstorm looks like. Don't read the words. I could not find a better one for this. But those are the three main stages of a thunderstorm. Let's talk about the types of thunderstorms. So I know it's weird to think like thunderstorms have different types, but we need to understand because it then also explains severity. So all thunderstorms come with wind and rain or like precipitation of some sort. Lots of updrafts and downdrafts. But what makes them different is their intensity. So single cell thunderstorms, these are the most common. These are what we see most of the time throughout the summer. These are 20 to 30 minutes tops of like that vigorous mature stage. Multi-cell thunderstorms, these are clusters of thunderstorms that just kind of like one on top of another after another. So this is these can last hours, producing heavy rain, strong winds, maybe a little bit of hail. You typically don't see like big hail. This is little ones. But they can last for several hours. So this is, again, maybe a full day of rain, but it's just one thing after another. Supercells. These are super duper rare because, again, you have to have such a perfect mix of ingredients for it to actually develop into this large of a storm. So this is the most powerful. It can produce tornadoes, it can produce large hails, and very damaging winds. So those are the different types. When you start getting those tornado watches and warnings and things like that, it's because we have a supercell moving in, that sort of a thing. They do not always produce tornadoes, but they have the makings to produce a tornado. Lightning. So I remember getting a call from one of my friend's kiddos when he was little. It was a couple of years ago even. And he's like, Kelsey, explain lightning to me. And I'm like, oh dear Lord, kiddo. But lightning it's so much more than what I can even explain because it's electricity and that's out of my field of expertise. So when you have movement up within our atmosphere, you have air moving and particles moving, but within that air, we have to remember there's like dust and debris and little things that when they come and they move together, they interact with one another. And this essentially causes static, just like if you were to rub your feet across your carpet and then go and try to touch someone. But lightning is essentially just a buildup and discharge of electricity within a thunderstorm. So we have positive and negatively charged atoms that separate within the cloud. And this is where if there's too much, like typically there's lightning happening within these thunderclouds often, but it's more like that static that, like, again, when you rub your feet against the carpet and then you go and touch someone. That's what's happening a lot within these thunderclouds, but sometimes when you get enough buildup, this is where it becomes too great, too massive, to where this entire bolt jumps. So lightning jumps from the cloud to a surface of some sort. We're going to talk here in a moment about like safety things, but it's so unpredictable because we don't know exactly if there's going to be a lot of discharge or not a lot of discharge, and where is it going to end up jumping to and all that kind of fun jazz. Okay, so but lightning is essentially just that movement of that energy within a thunderstorm because you have all these little particles and stuff that are just creating energy. Thunder, the roaring sound. So thunder is a after effect of lightning. Lightning moves so quickly that the air around it expands, and then contracts, and that's what actually creates the sound of thunder. So lightning heats up the air around it to extremely high temperatures and it rapidly expands. And then that rapid expansion creates a shock wave that travels outward as the sound of thunder. So thunder is not something you can actually see, you only feel, because it's just sound waves, versus lightning is all electric and like those sorts of waves. So that's what's up, just in case you didn't know. Let's talk about safety during a thunderstorm. Let's stay inside. Mainly because of the lightning is why you want to stay inside. Like, I was watching Bluey last night with Will, and it was the rain episode. And like, yeah, when it's just chill and little like dribbles or whatever in that like dissipating stage, it's not safe to be outside, but it's okay-ish to be outside. Just be cautious of your surroundings. So stay indoors as much as possible, mainly because we don't know if things 100% can produce lightning or not, and we don't want the lightning to jump from the cloud to you. So that sort of a thing. Plus, just rain can create hazards as far as like disorientation and distort your visual to where if you're driving and like your wipers are going or whatever, you don't know exactly where you are. So very similar to blizzards in the fact that it can make someone make turns before they need to make a turn or after they should have made a turn, or just slip because of fishtailing on the water and things like that. So stay inside as much as possible. Avoid open areas, tall trees, and bodies of water. We know electricity is trying to find the nearest source to become grounded. So that's why, like, tall trees. It's going to jump to the tree, hopefully, because it's just trying to find the quickest way into the ground. Water. Electricity and water don't mix. Period. So avoid that. That's why in the summer, if you're out on the boat, be in the boat and try to be getting to shore. Things like that. Do not use electrical appliances or telephones. Now, this is one that I never understood growing up, but then I experienced it at my grandparents' house. Their house took a lightning strike, and like everything kind of glitched out. Some things were like because of the circuits and the way that they wire your house or whatever. A lot of breakers just tripped, but sometimes if the breakers don't trip because it's just not enough energy or whatever, it can literally destroy a lamp. Things like that. So mainly like don't have your phone plugged in because it could be fried if your house takes on a lightning bolt. So that if you are caught outdoors, because it happens, excuse me, it happens. We're outside, we're enjoying a summer picnic or whatever, and all of a sudden, before we know it, we have a storm that moved in really, really quickly. It happens. But if you are caught outside, please try to find some sort of a sturdy shelter. You want something that is grounded to the surface. Tents are not great. Things like that. Don't go under a tree. Just try to find shelter, and if not, a vehicle would be really, really good. Okay, so those are all things. We know thunderstorms. What we need to talk about is hail and tornadoes, because those aren't things that we experience as often or frequently. But this is the end of whole group. So if that's all you needed to watch, fabulous. If not, keep up with me. Let's get going. So hail, icy balls of destruction, and really they can be. So typically hail comes with thunderstorms, but the presence of air and things like that is what allows them to get as large as they can get. So let's talk about some of these things on how hail forms. So hail really only needs two things to go. Okay, it needs a lot of updraft and it needs moisture. So An updraft. This is where the wind kind of like swoops upward. So carrying, like, updrafts happen within thunderclouds all the time. So as water droplets are trying to come down through that cloud, if an updraft comes up, it can force the raindrop up. Think of like when your grown-ups get the car washed and the blow dryers just don't do what they should do. And then you start driving and you see the little driplets of water going up the windshield, sort of a thing. That's what's happening in an updraft. Okay, but when the air pushes it up, pushes it higher into the atmosphere. As we progress into our atmosphere, it gets colder. So these water droplets can freeze. Okay, so that's where that happens. Okay, so freezing temperatures. Then as it tries to fall back down, because now it's heavy, or the updraft suppresses a little bit, it's colliding with all these other little water droplets or other little ice slushy things, and it's growing larger and larger. It's coming down. Now, the stronger the updraft, the more times it can get pushed back up or aloft, and the larger and larger it gets, to where if you were to actually cut a hail piece in half, it would look like a jawbreaker. Many, many layers built on top of each other. So if this updraft is strong enough, it'll keep pushing it up until the hail becomes so large and so heavy the updraft can't push it up anymore, and then it just naturally falls to the ground. So the stronger the updraft, the larger the hail can become. Most of the time in this area, like when we get hail, we get just itty bitty ones to where it's like a good updraft or two is what's just kind of throwing it up there, and it's coming down smaller than pea size. But when you like listen to the news about those major ones happening typically a little bit south of here, and you get like golf ball size, it's because that updraft wind was so strong it kept pushing it up however many times it needed to get to that size. So here is just, I think this is a better explanation, or like just to show you. So we have our big thundercloud, cool, fine, whatever happening here. And then you have the water droplets that are trying to come down, because that's just what happens. There's too much moisture, they get heavy, they want to fall. Okay, fine. But if you get this random updraft of air pushing this little guy up, okay, now it's crossing that freezing line to where this little droplet can turn into a little ice nugget and get thrown up. And again, gets thrown up, it convects down because it gets too heavy, it gets too cold or warm, whatever, and it starts to fall down, and it passes through again. And if it gets caught in that updraft again, it goes up even more. Hi, sweetheart. Sorry, Will's up. He's over there. So if that little hailstone gets caught in the updraft, once again, it gets thrown back up there, and again, it accumulates to where it moves from a smaller stone like this to larger stones. And yes, eventually, because of the mass of the larger stone, it's just naturally going to fall along with the downdraft and come crashing down to the surface. And that's where we get more of that damaging sort of hail. So, types of hail, and maybe types isn't the right, it's size. Okay, so we have small hail. Small hail is less than 1/4 of an inch, about the size of a pea in diameter. It causes little to no damage. What damage it might cause is to like weaker plants or seedlings or things like that that are trying to grow at that point in time. Medium hail, this is 1/4 of an inch to 1/2 an inch in diameter. So marble to walnut size, and these can start to cause damage to vehicles, and then again that tender vegetation, so leaves might be a little bit crumpled, or plants and things like that, but this is where you can start getting little dents in your car. Large hail, this is some scary stuff. So this is 1/2 inch to 1 inch in diameter, golf ball to baseball size. This is going to do significant damage to homes, their roofs, cars, crops, things like that. And then giant hail, which is very, very rare, but it's an inch or like bigger, larger than baseball size in diameter. It's rare, but it is incredibly destructive, and causes severe damage and even injury. This is stuff that can like knock you out. If you think of how far they have to fall from the cloud down and all that, it's not going to end well for anyone. So the damage that hail can actually cause is to property, crops, but then also to people, if we're caught in it. So hail can damage roofs, siding, windows, and cars fairly easily. Crops can destroy crops, leading to like an agricultural loss. So if like there's a major hailstorm that went through like Florida, some of their orange crop might be lost, to where that's where we get that inflation in price in oranges coming from Florida, things like that. And then injury. Goodness forbid you're caught out there with large hail. It can cause injury to people and animals who happen to be caught outside. So head injuries especially, things like that. So we need to know how to protect ourselves. The best way to stay safe is just to seek shelter indoors. Be inside. If you are caught outside when one of these rolls in and then you realize, oh crap, there's hail, like find a sturdy building or enclosure to protect you. Now, you want to be cautious of what kind of a structure you're choosing, mainly just because of the risk of lightning. But these are the things that you kind of go hand in hand with thunderstorms. Okay, if you are caught outside and there are no buildings around, okay, how many like of our parks truly have some sort of shelter? So you need to take cover in a low-lying area, such as a ditch, and avoid open fields and tall trees once again. But the thing is that they don't mention is that you should also be trying to protect your head and your neck. Okay, very similar to like when we do tornado drills in the building. You need to protect that, because if it gets large enough, you're going to cause injury to your head, and we want to make sure we're keeping that sort of stuff safe. Okay, if you're driving, don't attempt to outrun a hailstorm. It's not going to work. What you need to do is honestly just pull over. The thing that I'm going to urge you though, once you start driving, do not stop underneath an overpass. You're like, oh, but I need to protect my car. Cars can be replaced. But the thing with overpasses is it actually can cause a lot more damage to concrete, and overpasses can be compromised. And concrete, not as easy to repair as body detailing on a vehicle. So just pull over to the side, make sure you have your hazards on, you're pulled off enough to where people who want to keep driving can keep driving, and just wait it out. That's the best thing I can recommend. But yeah, so just avoid overpasses because they get clogged up. Plus, I think technically emergency vehicles have the right to those. Goodness forbid, like they have to do something like underneath it. I don't know. Tornadoes. So nature's fury. Let's talk about tornadoes because they don't happen very often around here, but when they do, they do. So what is a tornado? Essentially, it is a violent rotating column of air that extends from a thundercloud all the way to the ground. This rotating air forms a funnel shape, as we know, the tornado shape, but often is visible as a condensation funnel, just a cloud funnel. Okay. Tornadoes can vary greatly in size, strength, and path length, and all of this. Technically, my family had a tornado pass through our neighborhood in Detroit like a quite a few years back, but didn't even know it was a tornado until like meteorologists came and said, oh, there was an EF1 tornado that went through Detroit Lakes. And I mean, we had several downed trees, but yeah. So they vary, and you may not always know that they're happening when they are happening. How does a tornado form? Again, that warm, moist air, all of a sudden rapidly rising. So we get very, very warm, moist air near our surface most of the time during summer. But it's when it starts rising that meteorologists get interested. As the air rises, it cools and condenses, forming that thundercloud. Sweet. Within that thunderstorm, though, with those updrafts and those downdrafts happening, if they are kind of sort of situated oh so perfectly, what happens is that those clouds can start to rotate and they start creating this column. We call it a mesocyclone. Cyclone meaning spinning air. Meso, I don't remember. I'll look it up and I'll get back to you. But then this can start to happen. Now that's why people start kind of warning about like, oh, there's some circulation happening in the atmosphere, things like that. It's when the mesocyclone starts to stretch vertically. So they typically like to stay kind of like flat like a disc. But it's when it starts to stretch vertically and become narrower, that's where we start getting those like, oh, you should seek shelter, okay? Because this essentially creates that funnel cloud as a mesocyclone extends down toward the ground. So tornadoes don't have to touch the ground. Oh my goodness. They just have to have that cycling, rotating column of air, and that's where it can start being defined as a tornado. So there are multiple types of tornadoes. We are more so used to that classic cone tornado, which is the last one listed, but it is this picture. So a waterspout tornado forms over a body of water.
Mama?
Yes, Will. Now you know he's alive. Multiple vortex tornadoes. These are really rare, but this is where two or more funnel clouds come like rotating around a common center. So like they form from the same mesocyclone cloud, but then like multiple like tentacles almost kind of come off. That would be scary if I saw that, but hey. A land spout, which is a weak, short-lived tornado that forms over land, but often associated with non-severe thunderstorms. So this is where you get that rotation, but you didn't have everything else kind of like adding with it. And then finally, we have just our classic cone tornado. This is obviously the most common of tornadoes, with the very distinct shape, and extends from the cloud all the way down to the surface. So singular, still very destructive, things like that. We measure our tornadoes on the Fujita scale, or the EF scale. Now, the Fujita scale is used to classify tornadoes based off of the amount of damage that they have caused or will cause, but most importantly, based off of wind speed. Okay, so we have an EF0, which is the weakest. It's still a tornado, but it's not going to cause nearly as much damage as, say, an EF5, which is the strongest so far, with wind speeds increasing in each category. EF0 creates minor damage. You're going to get damage no matter what, but minor damage compared to EF5 is like complete devastation. This is like what went through Joplin, and totally took down an entire town. So what we're looking at, like wind speeds are ridiculous. An EF0 tornado, which is the weakest, can still have winds up to 73 miles per hour. You can barely go 75 miles per hour on I-29 heading north. Like, so it's getting up to those speeds. And then it just increases from there. I don't believe an EF5 has a limit. I think it has a minimum. I don't know that minimum off the top of my head. I will, again, look it up and get back to you guys. But it doesn't have a maximum limit. So everything's measured on the EF scale. Now, the thing with the EF scale is that it can cause for some confusion, because if it's based off of the amount of damage that's being caused, well, some places are going to look far more damaged than others just because of the infrastructure that's in place. It's very similar to the Mercalli scale with earthquakes. Like Haiti has a different infrastructure than Japan. Japan's Mercalli scale is very, very low because they have the money to put into the building of their structures and things like that, versus Haiti doesn't. So their Mercalli scale, even though it's a same magnitude earthquake, it seems much more destructive in Haiti than it does in Japan. So that's kind of similar with the EF. If a tornado goes through this area, it may not be as bad as if it goes through, say, New York City, sort of a thing. So let's talk about the difference between a tornado warning and a tornado watch. And this is my all-time favorite thing to show. So it's vital to understand the difference between a watch and a warning, because it essentially tells you whether you need to seek shelter or not at this point in time. So a tornado watch is indicating that there are conditions that are favorable for tornadoes to develop in a specific area. This is what I like to say prepping. Okay, so a tornado watch is like, okay, I'm gonna have tacos tonight, so I need to make sure I have all my ingredients, that sort of a thing. Versus a tornado warning signifies that there has been a tornado that has already occurred and you need, like within your vicinity, and you need to seek shelter immediately. That means, hey, it's taco night. It's happening. That sort of a thing where you've already made the taco and now it's just enjoying it. So if that helps you or not, that's what I got. So a watch is essentially just all of the makings of a tornado. A warning is there is a tornado. So a little fun thing for you. Safety things to keep in mind during, before, and after a tornado. So before a tornado occurs, like when you're in that warning sort of a stage or whatever, you need to understand your community's warning system. We have great tornado sirens that get tested, what is it, every first Wednesday of the month, and then I think in Horace they do it at 9 o'clock in the evening, and things like that, to where it's like, I know when it's time. It's either 6 or 9. I can't remember off the top of my head right now. So we have that. We also have, again, access to phones that will tell you when things are happening. You should always make sure that, if tornadoes are possible in your area, that you have some sort of a safety kit, including food, water, first aid, battery-powered radio, flashlight, things like that. Second thing is when you seek shelter, make sure you put shoes on, or have a pair of extra just tennis shoes or something down in your tornado sheltered area with your safety kit, because think of what sort of destruction you could be walking out on. So to make sure you have shoes. Not something I thought of until we had Will, and then I'm like, oh, yeah, that makes sense. During a tornado, if you're indoors, go to the lowest level in the building, preferably an interior room with no windows. Get under a sturdy piece of furniture, heavy table, workbench, whatever. Cover your head with your hands. If you don't live in a multi-level home, say like a mobile home, get out immediately and take shelter in a sturdy building, or make sure that you get yourself in the safest place possible. Typically this is a bathroom, in a tub or shower sort of a thing. So that, if you're in an apartment complex, try to get down to the lowest floor. So that if you're caught outdoors, lie flat in the ditch or other low-lying area, cover your head with your hands, all that kind of stuff. So just be cautious. And then after a tornado, once the storm is actually passed, you know, I'm trying to pull a Midwest dad where you're like out there like, oh, watch this going on or whatever. Just stay safe, please. Once the storm is actually passed, check for injuries, call 911 if necessary, stay away from downed power lines or damage to things like that, and then watch for possible flash flooding. Typically, if you have like major tornadoes go through, you have a lot of moisture, a lot of rain, and things like that. So, yeah. Those are the fun things about like our weather. This is getting me kind of excited about spring and summer, but that's just weird old me. So, awesome. There is a check-in, hopefully, that I finished. Debatable. A check-in, but make sure that you get your notes completed and handed in. And if you need anything, just ask. Thanks all.